Well, dear ladies and gentlemen, welcome to the next presentation. And it's an honor that I can speak here in a certain matter, which is a certain area. If we look to the last presentations that are regarding projects, and we have seen the presentation from Plug Power regarding electrolyzers. I would like to put the focus on a certain area, which is the flow control. Due to the fact for the sustainable value chains of green hydrogen and so on, we require the flow control for certain areas and certain applications. Let me kindly introduce myself. My name is Guido König. I'm responsible for the industries management at SAMSON AG, which is a flow control company, and we're doing the full value chain regarding the different processes of the hydrogen value chain. Let me kindly give a short introduction to SAMSON. As mentioned, it's a flow control company. What is flow control? Whatever media is flowing through pipelines, or it has to be controlled, it has to be performed, and this is the idea of the products of SAMSON. We're doing any kind of medium flow control for any kind of application. In addition, in order to do this in a sustainable way and continuous way, this is performed for the full life cycle. In order to monitor the performance and to have the efficiency really, we supply as well the digital solutions on that the flow control can be performed in a good manner and with a high efficiency. Of course, in this area, it's a small part of the full application, but it supports the efficiency and the sustainable value chain for hydrogen production, logistics, as well as the utilization. But what do we mean with efficiency? Efficiency in this case is just the energy efficiency as well as the resource efficiency for the production of hydrogen and the transportation. In order to have all this available or to support sustainable value chains, we have started our own initiative to do our own operations for circular economy, meaning that we have a design for our products which have integrated serviceability, safe designs, as well as long durability, and the design of the products is fully modular, meaning that you can utilize the products in its applications if you have to scale up your applications. So you can utilize, you can continue to use this kind of products. In order to really be on that way, we have decided as well that we move our own production facility in order to support the sustainability to a new site, and we do that we reduce our own carbon footprint for the products that are later used for the sustainable value chains with a net zero target, and to perform the first part as well. Let me kindly shift, and we have just seen the last two presentations of that area where we had electrolyzers from Plug Power and as well an interesting project from Air Products, which owns the liquefaction. And I would like to put the focus on these two areas of the holistic sustainable value chain, so regarding electrolyzers and as well regarding the liquefaction. Of course, as mentioned, flow control is required in all areas, through the whole value chain, but specific new requirements we find especially in the area of the electrolyzers and the liquefaction. Just looking to a typical water electrolyzer system, we can really see that comparing to classic electrolyzers, which are used in the chlorine production, for example, they typically run 100% of the lifetime on nominal power, on full power. Whereas if we now have electrolyzers which are supplied by renewable energy from wind turbines or photovoltaics, you will see fluctuating power supply to the electrolyzer. So to have the electrolyzer with full efficiency, it is necessary to have really the capability that the electrolyzer can run on partial load to continue to be efficient. As well, if we look what is produced by the electrolyzer is not just hydrogen, it is as well oxygen. And if I remember correctly, in the last presentation by Plug Power, currently the oxygen typically is vented into the atmosphere. To be fully efficient, we have to utilize the oxygen. But to be honest, as well, the hydrogen and the oxygen produced by the electrolyzer owns moisture, and that requires as well certain valve selection that we can control the hydrogen as well as the oxygen in an efficient manner to be utilized later on in the next application. Of course, as well, regarding the flow control, the field instrumentation has to own certain certifications as well as the capability to be run in explosive atmospheres. You may ask, what's the solution? What is the SAMSON solution to optimize or to have the electrolyzer system under that conditions in an efficient manner? So therefore, it is required that the now large-scale electrolyzers are capable to run through all the different loads, and that requires control valves with an extended rangeability and special inner parts that can handle the wet hydrogen as well as the wet oxygen. So an enhanced material selection, enhanced control valve design that can easily handle this kind of operations. As well, to ensure full safety, it is required to have a really absolutely tight sealing system of the final control elements to avoid any leakage of the hydrogen or as well the oxygen into the plant. So to combine both things, you have the necessary basic part to ensure an efficient operation of the electrolyzer, utilizing enhanced flow control solutions. Let's shift the focus to the liquefaction. Of course, it requires extremely low temperatures, and this is an enhancement or a requirement that is, let's say, extended to the typical cryogenic applications. Because for air separation and something like that, the typical temperatures are running down to minus 196 degrees C. Now, as well, the design for the final control element has to be capable to run on minus 253 degrees. As well, a certain material selection that avoids hydrogen embrittlement at that parameters. And this is interesting. If you have standard applications with hydrogen in the gas phase, you will find a lot of materials, different kind of steels that are capable to handle the hydrogen embrittlement easily if it is in the gas phase. It is different if you look to these cryogenic temperatures below minus 250 degrees C. There you require an enhanced material selection to avoid this hydrogen embrittlement in the liquefaction process and in the handling of the liquefied hydrogen. As well, to get an efficient operation due to the fact that we have these low temperatures, and as well we require a continuous running of the liquefaction process. It has to be ensured that maintenance operation can be done without dismantling the liquefaction plant from the isolation. So it is a special design necessary that allows any maintenance action on the final control elements, on the valves, that is possible without dismantling the valve or without getting the valve out of the process. So a so-called top entry access, that you can do everything from the top as well for the inner parts of the valve. So just two focus points, two focus applications where we can see that enhanced flow control can support the efficiency of the processes within the sustainable value chains, either, for example, for the electrolyzers as well as for the liquefaction process, as two puzzle parts within the entire value chain. And I would like to invite you to discuss some more details, some more solutions at our booth here directly C26. And thank you very much.